Myself, Dr. Anoop, as you have heard the introduction from Sir, that I have completed my PhD from CUSAT on text mining, NLP, and information retrieval. Currently, I am working with Kerala Blockchain Academy, which is India's first government initiative in the blockchain education space. And we have started with the world's largest accelerated blockchain competency development program called ABCD from the Kerala government funded. And currently we have trained around 12,000 plus candidates on blockchain technology with the different certification programs, both in online and offline modes. Both are in free programs as well as for paid programs. So our self-learning or self-paced courses are available at learn.kba.ai. Like if you are interested in learning the basics of blockchain technology, you can visit this. There are 4 free courses out there in different technologies, and you can obviously get certified. So KBA is I mean, these are our partners. Just to give you an introduction of the organization that I'm representing, we are partnered with Intel, Silica, Niti Aayog, Bayrak, Hyperledger, and all. And in today's session, we will be learning about the data visualization and the proposed contents that we will be going through in this session would be on a data visualization. What exactly is it? History of data visualization, why data visualization, and how the data visualization techniques will help businesses. Then the data visualization process, how we can do the visualization, the importance, the type of data relationships that you need to keep in mind when you go for data visualization, the types of charts and graphs, then the graph visualizations. Some of the tools will also be familiarized in the session that you can use for data visualization, and some interesting examples out there already been published that will also we will see to understand how sophisticated the current data visualization trends are. Okay, so I mean, we will be seeing the formal definition of data visualization later. But now, if I ask you the question, what exactly is data visualization, you will be seeing, okay, visualizing data. So, what is data? You all knowing, right, from the earlier classes. If you, I mean, for example, if you are from a computing background, this is the first term that you will be familiarized with before learning any subjects, right? Data. What is the definition of data? You know, data is a raw facts. We like often hear the definition data meaning raw facts, right? It is raw facts. Raw meaning it is not processed. Okay, so I mean, there is something that is missing from the raw facts. That is called the context, right? We have no clue about some raw facts that we have in our front, right? That we see, right? We need to add something to it that is called context, right? To enrich that facts so that the data will be transformed into information, right? So we start with data, then we add context to it, then that will become information, right? And we will be asking several questions to questions on those information to gain some insights, right? And that is we call it as knowledge, right? Knowledge is distilled by asking several questions. Why that happened? Why is it so? Are there any relations? All these questions will be asked to information to distill knowledge, and this knowledge will become other insights, and that will become the say the intelligence and all those things. We give say intelligence to the computer, and we will be seeing that as artificial intelligence, so and so. But the starting point is always data, right? Data is raw facts. I mean, without context, that is useless. We will be trying to add context, and that will become information, right? So there is a visualization part. What is visualization? Visuals, because that will be something some user can easily interpret, and that will be using several charting techniques or graphical techniques to tell the users, okay, this is the data that we have. So data visualization is nothing but just a graphical representation of data and the information, right? So that the user will be understanding more, rather than like going through a CSV containing or a comma separated value file containing or a text file containing say millions of words or data, right? It will be very difficult for us to go through each and every data point and understand what this data is all about. So rather we can plot those data points into some visualization techniques that we will be seeing later, which are the visualization techniques that we can use. But simply, if somebody asks you what is data visualization, you can just say this is just a graphical representation of information and data. Okay, we use several visual elements. Visual elements meaning the components that we will be using for visualizing this data, right? It can be charts, it can be graphs, it can be maps, or any other techniques that are relevant for that context. So data visualization tools will provide an accessible way to see and understand trends, outliers, and patterns in data, right? So for example, if you are analyzing the sales data of a company, you will be having a downloaded data from their database, right? That will be having rows and columns and several fields like the transaction ID, the transaction date, the customer details, his phone number, the amount, so on. So a lot of data will be there, right? So it will be very difficult for you to go through each and every data, every column of that data, and to try to understand on which day the maximum transaction has been recorded, right? That is very difficult if you have a say 1 million data points with you. So in those cases, data visualization will help you. It will be providing an accessible way to understand the trend. Okay, is the sales going up, right? On which day the sales has gone up? Is on which day the sales is very minimal, right? What is the pattern? What is the trend? So to analyze all those things, you need to have a visualization technique. Okay, but you will be just thinking, okay, what is a big deal with the data visualization? We can simply plot a graph, but there are many things that you need to learn before you find out the relevant visualization element, right? You need to clearly go through the data that you have in your hand to understand what exactly, which type of relations this data is having. Then only you can choose the appropriate visualization technique and then plot it. Okay, so if you visualize, if you use any visualization techniques and plot this data, then the data will become more natural. You can ask more and more questions, right? You can ask the questions which on which date the transaction has gone up. Then you are finding out information from this data. So I believe I was able to like convince you the relevance of data visualization, because the data lacks context. If you want to find out the patterns, outliers, the trends, etc. from this data, you need to have a visualization technique, appropriate visualization technique. Then only you can easily find out the answers for several questions. Then the data will be transformed into information, knowledge, and intelligence, right? So that is the relevance of data visualization. So it is worth noting the history of data visualization, because the current interactive plots, charts, and visualization techniques that we use with a single click or a single library was not the way people were visualizing information maybe several decades back, right? So it is always interesting to keep this in mind from where it has started, right? So prior to the 17th century, data visualization existed mainly in the realm of maps, displaying landmarkers, cities, and roads, right? So like it is very interesting to note that the visualization techniques were there even before 17th century, but we cannot even call it as visualization. They were just plotting something that is written or drawn on a piece of paper, then marking things with the stones or any other the landmarkers. I mean, all those things will be just drawn on a piece of paper. So that was the visualization. That we cannot even call it as a proper visualization. But in 1644, a person called Michael Florent van Langren, he's a Flemish astronomer, and he's believed to be to have first provided the visual representation of some statistical data. So before that, there was no visualization. There was just plotting things on piece of papers. And this Van Legren, who is an astronomer, could plot something on a piece of paper, and you can see the visualization he has used here, right? So these all are the names of stars. Then he has plotted all these things. The distance of this from the cities of Roma. So you can just see the very early intervention on the data visualization, right? So I mean, this is considered, or this person is considered to be the first provider of the very first visual representation of statistical data. Then later, in 18th century, saw the beginning of thematic mapping. So thematic mapping is nothing but based on a theme. You can plot the data points, plot the visualizations, or any other graphical techniques, right? And in the 18th century, we have seen the beginning of thematic mapping, that is again advanced from 17th century. And William Playfair, and he's a person widely known as the inventor of many of the most popular graphs that we use today. We all, right, have might have plotted at least one chart or graph in our techniques, right? The majority of the charts that we have plotted in our during our studies or experiments or projects were either line, bar, circle, and or pie charts, right? So William Playfair is considered to be the person who have developed these charting techniques that we use today, right? But that was not so sophisticated as we see today. But anyway, he is the person who have started it, right? So the line, bar, circle, and pie charts are considered to be developed or drawn by William Playfair, right? And on this on this side of right, the presentation, the screen, you can see a graph who have I mean that has been developed by Playfair in 1821. Shows the price of wheat, the weekly wages, and reigning monarch over a 250-year span from 1565 to 1820. So if you check this graph, again, this is a thematic mapping, right? It is drawn on a piece of paper, but it shows the price of wheat and weekly wages of employees from 1565 to 1820. Again, you will be seeing this is just a drawing on a piece of paper, and you may not be in a position to correlate with the graph that we see today, right? So, but these are the starting points of visualizations that we use today, right? Then the latter of the 19th century is called what Friendly calls a golden age of statistical graphs. More and more advanced techniques and thematic mappings were introduced during this time, right? You can see two famous examples of data visualization here. One is the map of cholera outbreaks in the London, that is epidemic that happened in London in 1854. And here the number of men in Napoleon's 1812 Russian campaign army, with army located, indicated by the x-axis. This is just plotting the location. Then the casualty has been plotted here out of a war. So this is again some examples on the history of data visualization from where it has started. Then the latter half of the 20th century is what Friendly calls the rebirth of data visualization. The rebirth of data visualization. So during the 18th century or 17th century and 18th century, the computers were not there, right? So the hardwares, right, that we want to plot or the digitization was not there at that time. But the 20th century is what I mean. The digitization has been has been happened. The computers, the hardwares, the softwares, and all those things were invented. but not as we see today. But anyway, those were treated as the rebirth of data visualization. And the early 80s saw the emergence of a famous person. This person, his name is Edward Tufte. And Edward Tufte is the person who is found to be the father of modern data visualization and statistical analysis. Right? So his seminal work, his book titled The Visual Display of Quantitative Information, which you can see in almost all libraries across the world and is treated as a Bible for modern data visualization. This is the first edition of his book, right? The visual display of quantitative information. It is very surprising to know that many of the universities or academic institutions who is having a data visualization course as part of their curriculum is still using this name of this book as their reference book, because the many principles, the many techniques that we use today in the digital representation of graphs and plots have used the foundation, the underlying principles from this book. What is the name of that book? The Visual Display of Quantitative Information. So this is very important to remember his name. What is his name? Edward Tufte. What is his book's name? The Visual Display of Quantitative Information. If you want to see, or if you are very curious to understand the basics of visualization, then obviously you can go and check if this book is available, or else you can buy a copy. It is worth it. Okay. Then we have seen what is an informal definition of a data visualization, right? Then we have seen the history of data visualization, what has happened during 17th, 18th, and 20th centuries, and who is like the father of modern data visualization. Right? Now we will just see what is the formal definition of data visualization. So the earlier one, the just a visualization of data using some visual elements, was an informal definition. Now this is a formal definition. If somebody asks you a formal definition of data visualization, this is the definition that you can tell, right? So the data visualization is the process of acquiring, interpreting, and comparing data in order to clearly communicate complex ideas, thereby facilitating the identification and analysis of meaningful patterns. Okay, I will repeat. Data visualization is the process of acquiring, interpreting, and comparing data. What is the process of acquiring? You are taking data from a source. Okay, you are acquiring a data from the source. For example, a sales data, or else the healthcare data, the patient data, or else the financial transactions data. Right? It can be anything, or the geographic data. Right? It can be anything. And the process of you taking the data is known as acquisition or acquiring the data. Then you need to interpret it, meaning you have to ask a lot of questions and you have to compare data. Why you should compare? To communicate complex ideas or communicate the differences or similarities or trends or patterns or outliers from this data, and facilitating the identification analysis of meaningful patterns. So this is the thing, this is one of the crucial things every say the data scientist will be doing, right? The data science is right, it's already it's a booming right job sector, and we specifically call it as the sexiest job of the 21st century, right? But data visualization is one of the subtasks every data science professionals will be doing, but it is very complex, right? So why you need to do all these visualization which are very complex? Because you have to be a storyteller. If you want to succeed in a data science domain, you need to be a storyteller. You need to be a good storyteller. What is storytelling? You are playing around with the data, you are asking several questions, and the findings needs to be communicated to an audience who don't know much about the technical things. Okay, the managers, right? The decision makers of a company, they will be like take an MBA from from some colleges or great institutions, but they will not be knowing much about how to drill down the data, how to acquire the data, how to do the analysis. So you are there as a data science professional. You will be there to do all these tasks and to create very compelling visualizations to them and telling, okay, this is what happened. This is our sales is going. This is our say the HR or a payroll processes is going. Why we need to tell those story to them? Because those are the people, the managers are the people, or the stakeholders or the decision makers are the people who will be taking decisions about the businesses, right? How they will take the decisions? Will they simply take a decision, blindly take a decision? No, they need evidences, right? That evidences will be available in the data, but it is hidden, and you have to drill down the data to find those evidences. And based on that evidences that you will be presenting to the managers, they will take crucial decisions. What will happen if your data analysis or data visualization is incorrect? What will happen? Obviously, the decision making will be incorrect. What will happen if the decision taken by the managers are incorrect? What will happen? The businesses will be in loss. So it is very crucial that it is very important that you take the relevant data from the relevant sources, you ask the relevant questions to the data, then you do the or you do the relevant visualization technique so that the storytelling will be become much more easier. Okay, so this is just a formal definition you want to keep in mind. You should keep in mind if you're interested in data visualization or any aspect of data science, that visualization is the process of acquiring, interpreting, and comparing data in order to clearly communicate complex ideas, thereby facilitating the identification and analysis of meaningful patterns, right? And why we need to do this? This is the answer. The data visualization helps people understand the significance of data by summarizing and presenting a huge amount of data in a simple and easy to understand format in order to communicate the information clearly and effectively. I have already communicated this, right? I have already told you this because you need to convince, you need to present all these findings that you have done on this data to a group of people who are not from the technical background. They can only take decisions, and that the decisions should be backed by data, right? That is the duty the data scientist will be doing. Okay, so data visualization, right, plays a very crucial role in those processes. Why data visualization? Because you might have heard this quote: "A picture is worth a thousand words." Right? Whatever things that we will be trying to convey in text, right? In plain text, will have a limited reachability to the audience, right? So if you draw a picture and trying to convince something to the person, the reachability will be more. So this is one sentence every teacher will be telling the students while they will be approaching the exams, right? Even if you write, say, blah blah things for say 5 6 pages, right, that will not attract more marks. But if you draw a diagram, right, and explain things, then you will attract more marks. Why they are saying this? Because as an evaluator, as a teacher who will be evaluating the answer script, they will be evaluating say 100 or 200 papers, right? And what if they will be going through each and every line, reading all those lines and then putting marks? Rather than that, teachers will get more idea from a picture that you will be drawn on a piece of paper, right? A picture is worth a thousand words. That is why data visualization is important. Then the second point, the humans just understand data better through pictures rather than by reading numbers in rows and columns. If you have data that are just numbers or text, even plain text in rows and columns, uh, I mean, you will get bored after going through a couple of rows and columns. Rather, if you can visualize that, then that will be better. If the data is presented in a graphical format, people are more able to effectively find correlations and raise important questions. So that is why the data visualization is very, very important. Now, as I said, data visualization is having a huge impact on the decisions taken by the key stakeholders or decision takers or managers, right, who will be taking decisions based on data, or they will be taking informed decisions. Who will be giving that information? Of course, the data science professionals. And how visualizations help businesses. Just try to understand how the data visualization help businesses. The first point, converting the business data into interactive graphs for dynamic interpretation to serve the business goals, obviously, right? Keeping the data or a static data and going through the rows and columns would be very, very difficult, and it is very difficult to understand. So if you can plot those data using interactive graphs, then the dynamic interpretation can better solve the business goals. Then the second point, transforming data into visually appealing interactive dashboards of various data sources to serve the business with the insights. For example, a company will not only be analyzing data from a single source. There needs to have multiple sources. For example, the customer details will be in one place, or CRM, that is customer relationship management. There is for example, the sales data will be in another location. So if you want to have a 360-degree view, a complete view of all this information, then you need to combine multiple data sources, and you need to create dashboards. So dashboards are nothing. It is just like a screen that will be displaying multiple charts and visualizations in one place, so that it is very easy to understand a complete picture, right? That is also how the visualization helps the businesses, and creating more attractive and informative dashboards of various graphical data relationships. Obviously, this is done by data visualization and helping businesses. The fourth point, making appropriate decisions by drilling into the data and finding the insights. Then fifth one, drilling into the data, meaning you can narrow down your selections and see, right, what exactly the data is. Then figuring out the patterns, trends, and correlations in the data being analyzed to determine where they must improve their operational processes and thereby grow their businesses. Obviously, will help for decision making purpose. The last point, organizing and presenting massive data intuitively into present important findings from the data and making better, quick, and informed decisions with the data visualization. This is very, very crucial, because if the decision taken by the decision makers or the managers or the chief of the company will be incorrect due to, say, some irrelevant data or some noise or irrelevant visualization, obviously the loss that will be caused to the company will be more. So always you need to rely on the good data, a relevant data visualization, and a good storytelling. This will help them make better decisions. This is how the visualization help businesses. Then, as I said, the data visualization, it is not just about you get the data and you put it in some software or tools and create some visualization that even you don't understand, right? That is a bad data visualization process, right? So for example, most of the time we will be creating the visualizations which are irrelevant or which will not be conveying any meaning to the public. So rather than in some situation, for example, if it is a line chart or a bubble chart that is apt for the data, but you are creating say a pie chart, that will be very difficult. It will be showing some information, but that will be very difficult for the person who will be analyzing the chart to interpret things from the data. So that should be avoided, right? So data visualization process mainly consists of three steps. Those are filtering and processing, that is the first stage, translational and visual representation, that is the second stage, perception and interpretation, that is the third stage. Which are the stages? Filtering and processing, translation and visual representation, perception and interpretation. So while you create a visualization, you will be going through all these stages. The first step, filtering and processing. What is it? It is just like refining and cleaning data to convert it into information through analysis, interpretation, contextualization, comparison, and research. So when you will be getting a data set or a data from a location, you need to understand which all are the important, say, columns or important features that you should choose from it. Sometimes there may be irrelevant data, there may be some say values that are missing, or sometimes there are irrelevant or least relevant features available in the data set. So that will not help you to take a decision, or that will not help you understand the data better. So at sometimes we need to do all those pre-processing. You are just refining. It is just like you dig that crude oil and refining to get the petroleum products. Just like you have the data, you have to refine it. You have to go through the data to understand which are the features that should I take forward for processing, right? The second stage, that is the translation and visual representation. You are shaping the visual representation. You are trying to figure out the correlation or the relationship between the data and finding out which visualization technique will be apt in this context, apt in this situation, right? Then you will be drilling down the data, finding out the visualization technique, then you are trying to plot it, right? So the first step is filtering or pre-processing. Second step is translation and visual representation, where you actually plot it. Is it over? No. If you create a visualization and keep it in your custody, that will be of no use. You have to present it. You have to tell a story about this data to the managers, and that step deals with the perception and interpretation, right? You need to perceive, or the person to whom you are presenting this visualization should perceive what exactly is in visualization. Okay, this is the trend that is going on. Okay, this is the location where we are getting minimal sales. What should we do? So all those interpretations and perceptions should be taken. So this is the final steps for the data visualization. So this is very, very important. Like you will be going through these phases, going through these stages when you will be working on any data science pipeline. There will be situations when you will be dealing with the data pre-processing, data like translation, and then perception and interpretation, right? So these are the three stages that you can keep in mind: filtering and processing, translation and visual representation, and third one is perception and interpretation, right? Okay, cool, right? We are going to some advanced concepts, starting with the history of data visualization and to the important steps in the data visualization. So this one we have seen the importance of visualization already. We typically process images 60,000 times faster than a table or a text, right? Just an example, you can just see these two cases, these two figures. In the first figure, this is just a month-wise sales, say January, February, March, April, May, and June. The sales volume, right, maybe in lakhs from the month of January to the month of June. If I am asking you, you don't have to look at this image, the second image. You can only look at this table, right? If I will be asking you the question, which month has recorded the highest sales, right? So it will be, right, in this situation, it will be comparatively easy for you to understand the largest number from the second row, that is sales. And you can find out, okay, you need to check January, you need to check February, March, April, May, and June. And you can say, okay, May has recorded the highest sales. This is just 7 columns and 2 rows. But an actual company, it will be, say, 200 or 300 columns and say thousands or even 1 lakh, 2 lakh, 3 lakh rows from which if I will be asking you which month has the highest sales, then it will be very difficult for you to understand. Now look at the second image. What is that? In the second image, I have plotted it using a line chart. This is called a line chart, right? Where you can find just where the peak of this line, you can simply say this is the peak. Peak is 75. Which month? It is just May. So this is, you can just look at this image directly and say which month has recorded the highest sales, right? So this is the difference. That is why we say we typically process images 60,000 times faster than a table or a text. Then there is an interesting fact that we might have heard. There are 13 milliseconds and store the information provided that it is associated with a concept. Okay, so we will be storing that information, or like if it is associated with a concept or a visualization, we will be just storing the information in 13 milliseconds. But provided we need to have a visualization technique. Then a visual representation that uses images is a much more effective way to communicate information than text or a table. It also takes up much less space. If you want to display a large table containing all the sales data for a company for an year, that will be taking up a lot of say space, right? If you are visualizing that using an image, then it will be taking up less space. So this is importance of visualization. You can just see with this example. Now, okay, you have a larger set of data, and how the business's decision making, or what are the advantages of business decision making with the data visualization. The first point is the faster responses, obviously. Rather than going through the raw data, right? You can simply plot some relevant data visualization techniques so that the responses will be faster. The decision taking process will be faster. Simplicity. There are thousands of charting and plotting techniques or graphical representation techniques available out there. You can use the simple one that will be conveying more insights about the data. That is simplicity. The third one is easier pattern visualization. You have to plot the sales pattern. You want to plot the financial transaction patterns. You have to plot the, say, the climate data. So there are pattern visualization that will be very easy with the visualization techniques. There are team involvement. Most of the tools and techniques that we use today for data visualization supports collaboration. What is collaboration? Collaboration is nothing where multiple people can work on a single project, right? That is also applicable in the case of data visualization. You can build complex dashboards, right? With the help of your peers, your colleagues, you can work on the same thing. That is team involvement and unify the interpretation. The plot or graph that you will be created for one situation and that is presented to one manager can be presented to another person as well, unless the data changes, right? So that will create a unified interpretation among people. So these are the advantages of data visualization for business decision making: faster responses, simplicity, easier pattern visualization, team involvement, and a unified presentation. Now, now we are moving on to the different charting or graph techniques and its advantages. When you attempt to explain something through data visualization, you start with a question, right? You have created a data visualization. You start with a question. For example, what has happened, right? Why this chart is showing, or for a particular location, this bar is very high, or this line is having a peak at say 50, right? You will be asking a lot of questions on that, right? Which interacts with the data set in such a way that it enables viewers to make a decision and subsequently answer the question. Okay, so you have collected the data, you have used a dynamic visualization technique, and you presented that to the decision makers. Obviously, they will start with questions. Why this graph is like this? Or why there is a peak? Or why this location is showing this much of sales? Or which in which country we have got a maximum profit? So these are the questions, obviously, that they will be asking, right? And the answer to those questions are already available in the data itself, so that they need to interactively work with the graph or chart to find out the answer, right? You can just nowadays all the data visualization techniques are providing interactivity meaning you can drill down, you can drag and drop, you can scroll your mouse, right? All these things are possible. According to that, you can find the answers, right? So this is just a simple histogram that is a country-wise sales have been plotted for a particular company. So when you attempt to explain something, obviously it will start with a question, and the answer to that question will already be available in the data. Only thing that you have to do is to drill down, explore, and analyze the data. Some visuals have been designed to lend a data set in spatial dimensions or to offer numerous subsets of data in order to raise questions, find answers, and discover opportunities. There are different types of data and different types of visualization techniques. So some of the visualization techniques will be very static. You will not be having interactivity. Some of them will be in the spatial dimensions, right? The complex multi-dimensional data, all these things will be in a spatial dimensions, where the complex data will be visualized. And I will be sharing this PPT with you later. You can use this link to see, right, an interactive visualization that has been in a spatial dimension that you can check later. Some other visuals prompt viewers to inspect, distill, and transform the most significant information in a data set so that they can discover something new. Okay, some data sets or some data visualization techniques can plot data in a static way, some in dynamic way, but in a complex manner. Some of them will be helping the users to find the answers, to learn something new from the data. So that depends on the technique that you use for visualization and also the data that you are dealing with. Okay. Now, moving on to another interesting topic, that is data relationship. Okay, you have, let's assume you have the data with you. You have collected the data, or you have joined as a data scientist or a data engineer or a data architect, whoever the designation. We are dealing with the data, large quantities of data about a company. Okay, and the company has asked, okay, they have given you the sales data in a CSV format or an Excel format, and the company management has asked you to drill down the data and to find out how the sales value is going for the last quarter, last 3 months. Okay, and how you can do that? Okay, you got the data. Now we know, right? You have to do a lot of pre-processing to find out, are there any missing values, are there any irrelevant features and all, right? Then you will be you will become friend. Okay, you need to be a friend of that data. Then only the data will tell you more and more things, right? There was a person who said, the more and more you process the data, the more and more things it will confess, right? So you have to do a lot of analysis, right? Before going to visualization, you have to do a lot of things. So even many of the people who will be working with the data science domain will be knowing, right? If they want to build a dashboard, right? For the storytelling, building a dashboard is very less time consuming, or it is easy because we have many tools. Okay, but collecting, pre-processing, and analyzing of data will be a very time-consuming process. So 90% or 80 to 90% of the time that you will be spending on pre-processing the data and to find out the relevant data parts, right? And on the visualization part, you will be only taking say 10 to 15% to build the data visualizations. Okay, and one of the crucial steps in analyzing the data is to identify the relationships between the data, right? And it is right in this slide you can see 7 major data relationships, right? 7 major data relationships that you can find in any sort of data. The first one is ranking relationships. Ranking. Second is the deviation. Third is the nominal comparisons. Fourth is the correlation. Fifth, partial and total relationships. And sixth, series over time. And the last one, the seventh one, distribution. So you need to identify which data relationships exist in the data that you are considering. This is one of the very crucial steps associated with understanding the data, right? Ranking, deviation, nominal comparisons, correlation, partial and total relationships, series over time, and a distribution. Okay, so let's see some of them with the some visualization, something that you will easily understand. Okay, first one is the ranking. So what is ranking? Ranking is a visualization that relates two or more values with respect to a relative magnitude. For example, a company's most sold products. Okay, so this will be just like a ranking. For example, a company is selling a lot of products and you want to rank the products based on the sale volume. Okay, for example, you have say 10 items and the laptops have ranked first. So this line, this first line will be representing the laptop. Second, you have found out that the second most sold product is the mobile phone. So second one represents the mobile. So you're ranking based on certain magnitude. Okay, then there is deviation. Sorry, deviation. So the deviation examines how each data point relates to the others and particularly to what point its value differs from the average value, right? So you have a average sales value in in some months you will be having a raise in the sales volume. In some months it will be going below the average. So if you want to visualize or if you want to identify those kind of things from the data, the relationship is deviation. Then there is called a nominal comparisons. The product prices in various supermarket. You are taking say a particular product and you want to rank according to, or if you want to like compare them based on the prices for those products in different supermarket, that you can plot nominal comparisons. There are correlations. The correlation meaning, for example, if there is some relation, right, with a factor. One example is the salaries of a person based on the level of education. You want to find out if the level of education is increasing, whether the salary of a person is increasing. That is you have to find out the correlation. There can be positive correlation, there can be negative correlation, right? So you will be checking are there any effect on the level of education to the salary he is getting. Okay, so maybe a person with a +2 or a degree will be getting a less salary, and a person with a PG and a PhD will be getting much higher salary. So, but you have to analyze it. So that is the relation called the correlation. Then partial and total relationships. The subset of data as compared with the larger total. For example, the pie chart kind of things that you can use. The percentage of people buying products. For example, you want to find out how much or will that be purchased more by men or women, right? So you have a total sales value out of which you have to plot the portion of men and the portion of women who is buying things. So that is a partial and total relationships. And there is series over time. you are taking a monthly sales value, for example, January 1st to January 30th, 2022. How is the sales value going, right? Or else you are taking 2021 and 2022 and comparing how the sales were going with that period. 2 years, 21 and 22. That is series over time. Then the distribution, how the data is distributed spatially based on certain central values, the heights of players on a basketball team. That is an example of distribution. So similarly, you can see many type of relationships between the data, in the data, that is ranking, deviation, nominal comparisons, correlation, partial and total relationships, series over time, and distribution. If you understand these things, these seven things, then it will be very easy for you to understand the relevant chart technique or relevant visualization technique. Okay, but understanding these things may require some probability and statistics knowledge, but obviously this is very crucial to understand the data relationship. Okay, so just keep in mind these names: ranking, deviation, nominal comparisons, correlation, partial and total relationships, series over time, and distribution. Okay, now based on the things that we have learned so far, now we are moving on to some chart techniques that you can just visualize in your mind. Okay, so the first one is bar chart. This is one of the charting techniques that we will be learning in schools, right? We have a graph paper where we will be drawing some data points will be given, and we will be marking those points and drawing bar chart on a piece of the chart paper, right? So bar chart is one of the most popular ways of visualizing data because they present a data set in a quickly understood format and enables viewers to identify highs and lows at a glance. Okay, so different types of bar charts are there. One is vertical column. This is the most common one. Then the horizontal column is there. Then full stacked column is also there. Based on the situation, you can plot. For example, the first one, the vertical column shows the January to the sales, maybe in lakhs from January to the month of May, and it is growing, right? And the horizontal column, the second image that you can see, it is used to visualize the categories, okay? Which are the sectors the government is giving more attention. For example, a case, a data set that you're analyzing, you found that education is a sector, then entertainment and health. Then there are full stacked columns as well. All the categories will collectively add to 100%. If you check this one completely, this is 100%, out of which light blue may represent a 30%, this may represent a 10%, then this may represent a 60%. So in total, it will be 100%. So this is a bar chart, right? So this will be coming in the ranking relation. If you find that the data set is containing a ranking relation, then you can find out, then you can plot the bar chart. Then there are histograms. Histograms represents a variable in the form of bars where the surface of each bar is proportional to the frequency of the values represented. So there may be people who will be like interchangeably using the bar chart and histograms, but histograms right, there are differences between the histograms and bar chart, and there are also you can like visualize the histograms in two ways, either through vertical columns or through the horizontal columns, right? The negative values can be on one side and the positive values can be on one side. That is also possible to like visualize the histograms. So bar charts, histograms. Then there is pie chart. So the portions, we need to like take out the portions from a total contribution. So in such situations, you will be using pie chart. There are many pie charts available, but the two of them, the main variations of pie charts are the standard pie chart as well as the donut pie chart. And in the afternoon, I'm just mentioning all the theory things over here. And in the afternoon, you will be plotting this kind of charts and graphs in the hands-on session. So a pie chart consists of a circle divided into sectors, each of which represents a portion of the total. So if this is representing 100%, the portion of A is this much, say 75. Portion of B is this much, say 25. Right? Maybe the gender in a say a classroom, where say you can say the 75%, the A represents the number of girls, B represents the number of boys. That is possible. Out of 100, how many boys and how many girls? And there is something called a donut pie chart as well, where donut pie chart will be looking like this. It's a variation of pie chart. Then there is something called a scatter plots. You want to see the spread of points over a Cartesian coordinate. Cartesian coordinate is nothing like, just like there is an xy coordinate, where you want to show the relationship between two variables in a Cartesian coordinate, or a spread of points, right? How the sales is going like this, or how the height of the person is increasing, and all those things. So that can be used plotted using scatter plots. Then there is something called a heat maps. Heat map represent individual values from the data set on a matrix using variations in color or color intensity. So based on the intensity, we can represent values in a heat map. So sometimes you will be saying, for example, the climate conditions of a geographic location needs to be plotted, where you have to write a stress out. You have to give a high intensity color for those regions where the maximum, the drought is there, or maximum temperature is there, and there may be another locations where the temperature is very less, right? So based on the intensity, you can do that. In such situations, you can use the heat maps. Okay, this is called the heat map. And heat maps can be sub-classified into two: the mosaic diagram and a color map. This is called a mosaic diagram, and this is called a color map. Okay, I will show you some examples where these are being used. And there are line charts. I'm just mentioning only the highly relevant charting techniques. The line chart, the changes of trends over a period of time can be drawn. Like we have seen the sales line chart in a previous example, where we can just check the peak and say this is the like month where we have recorded maximum sales. Then there is bubble chart. It primarily displays three-dimensional data and which is used for visualization of three-dimensional data. Right. There are subcategories of bubble chart: the bubble plot and as well as bubble map. So bubble map primarily will be represented for identifying those locations. And for example, if you analyze this one, we can just interpret this as the number of COVID cases maybe around the world. The larger circle will represent there are more COVID-19 cases, and the smaller represent there are less COVID-19 cases. So, only after analyzing the data set, you will be understanding which data relationship exists there, and based on it, you need to identify the apt or relevant chart technique. Then there is something called a radar chart. It is like built around a regular polygon that is contained within a circle, where the vertices and axes are the places where the values are represented. The radar chart. We will not be commonly using radar chart, but there may be, for example, if you want to represent something that there the time is quantified. The time, maybe the month of the year or the days of the week, all these things are quantified, then a radar chart will be used. Then this chart, this is called a waterfall chart. This is again using to understand the cumulative effect of positive and negative values on a sequential fashion. This color represents the fall and the blue color represents the rise. There is a start and end. So between that, if you want to understand the variations of the values, you can use a waterfall chart. There is something called a tree maps. This is just like a say the decision tree kind of thing. It will be displaying things in a like tree structure, where the portions represents the decisions. For example, A start with 200, then B is 80. 80, there can be two categories, D, E, C can be three categories, so and so. So this is another techniques for visualizing it. Then there is area chart. This is area chart. Uh, there are different types of area charts. It represents the relationship of a series over time. This can represent volumes as well. Volume in the sense, if you are seeing this, say the area chart, the blue color, for example, in the first diagram, the blue color, the quantity, right? The volume is higher here in the blue color. So it will be easy for us to understand which area is right having the larger values. There are again different types of area charts such as standard area, stacked area, 100% stacked area, etc. This is called 100% stacked area because all the areas are covered. This is a standard area, just represent one value, and here multiple values, right? So this is again another type of area chart. So we have seen the minimal or the most commonly used charting techniques. Let me again stress you, identifying the relevant data and identifying the relevant relationship from the data is very, very crucial. Whether it is ranking, whether it is deviation, all those analysis should be done. Then based on that, you need to plot the appropriate chart. And it is just worth mentioning, there is a whole set of another visualization techniques. Those techniques are known as graph visualization. So you know what is a graph, right? So graph, which is also called a network, is a collection of nodes and edges or vertices or links, right? So we model, the humans model data in the form of graphs often. For example, the social network, your Facebook, your Twitter, or whatever be the social network that you are using, which can be modeled as a graph, right? Where each of these nodes representing the people and the edges representing their friendship, right? So this can be modeled. So there are many other cases. The knowledge graph, in the case of text mining and natural language processing, there are knowledge graph. This can be represented. So if you have something that needs to be represented using a node and edges, then obviously graph visualization will help you, right? So in a graph visualization, each node represents a single data point and each edge represents how these two nodes are connected. So in the case of social network, there are two nodes, say John and say Carl. So this John and Carl is connected with a line, meaning John is a friend of Carl or Carl is a friend of John, right? So this is a real life modeling. In real life, we can model this using graph. So graph visualization is also very, very important because nowadays there are a lot of situations where you will be analyzing the data in the form of relationships, right? So this way of representing data is very suited for scenarios involving connections like social networks, telecommunication networks, protein interactions in bioinformatics, and a lot more, right? So associations or relationships wants to be communicated, then graph visualization will also play a crucial role. So graph visualization is a visual representation of nodes and edges of a graph. Dedicated graph algorithms, then the graph algorithms, or if you want to do a graph visualization, there are very sophisticated algorithms and tools available out there that will help you create data visualizations in a graph form, right? Some of the graph visualization tools that you can explore later are Gephi. The Gephi tool is one of the most widely used one by the social network researchers. Then GraphViz is also there. Neo4j, again popular, where you can just visualize the graphs in a very easy manner. Networks, then PyViz. This is a Python library where you can create all this graph visualization. So apart from the charts and graphs that we have seen, there is a lot of research that are happening with the graph-based visualizations as well. So these are the tools that you can check later. Then there is another form of graph. This is a type of graph visualization, force directed graph. If you hear this term, just try to understand. This will be just a series of dots. In this graph, it will be just series of dots, and the shape or the size of the dot represent the intensity of relationships, right? So this part, the central part, you can just say these are my Facebook friends, and the lower dots are friends of friends of friends or something like that, right? That is not directly connected. The size of the dot is proportional to the number of items represented by the dot, and the thickness of the lines represent the significance. So if there you can see a thick line between these two because they are directly connected. They are directly connected as my friend. Okay. So this is used for network visualization, large graph visualization, knowledge representation, system management, etc. So those are a type of graph visualization that are called a force directed graph. Okay, just making you aware that there are situations where you will be having the data that is represented in the form of objects and their relationships. At that time, you cannot plot that in a line graph or a line chart or a bar chart. At that time, you may check for graph visualization techniques that will be better visualizing the data. Okay, just mentioning, we are coming towards the end of this presentation. The cycle of analytics, right? Now we have seen the data, we have seen what is information, the history of visualization, where it has started, where we are going, how to identify, why businesses love data visualization, the type of relationship, the type of visualization, all these things, right? If you are joining or if you are interested in the data analytics, primarily the cycle of analytics consists of 4 steps. One is data discovery, identify which data to be collected. Second is data preparation, as we have seen, pre-processing the data and finding out the type of relationships between them. Then the storytelling, meaning presenting it to the user. It is just like a circle or a cycle. So data start with data discovery, then data preparation, data analysis, storytelling. Again, when you tell the story, if they need more details, again you have to do the steps again. That is why we have represented this using a cycle. And visualization is a core part. In all these phases, you need to use uh, uh, some type of data visualization to make the process better understanding. Okay, so this is a cycle of analytics, and just some of the tips that you can keep in mind if you are going with a data visualization process or a data visualization kind of a job that is involving data visualization. Uh, the best practices for data visualization are: choose the best visual for your data and its purpose. This can only be done using thorough analysis of data, and obviously, as you design more and more visualizations and you gain expertise, then the process will be very simple. On seeing the data itself, you can find out the relationship. Otherwise, you need to drill down the data. If you're a beginner and you're playing with some sort of data, then the level of drilling down, the level of understanding the data will be much, much higher, right? Obviously, you will make mistakes, but obviously, try to understand the relationships that we have seen. Then the second best practice is to ensure your data that is easily understandable and viewable, right? Because that serves the whole purpose. If your data is not understandable, even if you present that using a chart or graph, then the whole purpose of the data visualization will be spoiled. Second, offer necessary context for your audience in and around your visual. This is very, very important. It is not just like you plot some graphs and create a dashboard and present to the user. No, there must be some clues, there must be some legends, there must be some textual information that you can place around your visualization to better explain. Okay, you can add some text. Okay, this visualization represents the sales value from the month of January to December 2021. right? And place appropriate legends as well. Legends in the sense the markers, the colors that represent each and every graphs, right? Those things will help your audience to better understand the context. Then keep your visual as simple as straightforward as possible, simple and straightforward as possible, because it is not all about creating complex visualizations and ending up with nothing learned from that visualization, right? It should be avoided. You can create simple chart techniques. For example, if you can plot a bar chart, that will be better describing your data. That is well and good. Don't go for a complex charting technique, which will be making the whole process difficult. No, you should not do that. And educate your audience with your visuals. Educate your audience meaning they just treat your say the person to whom you are presenting this dashboard. Let's assume they don't know anything about the data or the visualization. So you have to educate, or you have to create the dashboards in a better fashion or in a way that will be easy for them to understand. So these are the best practices that you should keep in mind when you are approaching a data visualization problem. And just see some of the data visualization, say some important tools and libraries. This is not a comprehensive list. These are some of the tools that I have used during my journey with the data science, and thought of sharing this with you as well. Some of them they may be paid versions, some of them will be free as well. And some of the tools are in the first part. The tools are the Google chart. So the Google chart provides the interactive like charting techniques. If you have a Google account, you can just use it. This is, I mean, for the basic purposes, or for a medium level kind of dashboard creation, this would be very okay. Then there is tools called a data box. Data box is some of their features are paid. Then Chart.io, Tableau desktop. Tableau is one of the very famous data visualization tool. The Tableau desktop version is there. Cloud version is also there. Desktop version is free. You can register and you can download the desktop, Tableau desktop, and but with a very limited features. Tableau Cloud will be having a paid version, and which is having a very feature-rich version. But you can freely download desktop to work with the CSV data to some sort of data visualization. I highly recommend Tableau. Then there is something called a Click. So Click is also there. Click is also something similar to Tableau with a cloud subscription, where there is something called a Click Sense, where you can analyze this data and do the visualization. And some of the Python libraries that I can highly recommend. Many of them will be introduced in your afternoon session, I believe. One is a JavaScript library. This is called d3js.org. D3 meaning data-driven documents. You can just visit d3js.org, where a lot of examples will be available. If you are good in JavaScript and the basic HTML and CSS, you can create interactive dashboards that can be publicly hosted and people can use it, which is very good. And other libraries are Matplotlib. This is Python library. Matplotlib is one of the most commonly used, say, the visualization libraries. Then Seaborn is also there. Seaborn library will also be used by data science professionals. There are plenty of examples and plenty of chart and graph techniques. With minimal code, you can create visualizations, compelling visualizations. That is the advantage of Seaborn and Bokeh. There is one library called Bokeh, which is also a Python library that you can check from this link, demo.bokeh.org, where the user documentations on creating all these all these visualizations will be given over there, right? There is Geoplotly library as well, something similar to Matplotlib, but for plotting the geolocations with the help of map and the political map and all those things. So these are some of the tools. I'm not saying these are all the tools only available. No, this is just a minimal set of the tools and libraries that you can check out later to understand how visualizations can be used. Right? Then there are some interesting examples. Maybe I will not be showing the demo now, but like I will be sharing the slides with you. There are like you can recollect from where we have started, right? Uh, from where we have started from charting the techniques on a piece of paper, right? Now we have like the data visualization industry or data visualization paradigm has taken altogether a different dimension, because now we are dealing with we call it as big data, right? The data set will be of very huge in size, right? That a traditional data visualization techniques may not be enough, or the traditional data visualization techniques will not be having that sophisticated capabilities to visualize large quantities of data. So now people are dealing with the say GBs of data or terabytes of data, and we need sophisticated tools and techniques for visualizing these things. So these are some of the say visualizations that you can check out later, where interactive visualizations have been created on, say, global warming, the languages across the globe, then uh, uh, scheduling of buses, all these things, very interactive visualization that you can check out later. These are all publicly available. And now we are coming to the conclusion, where in today's session we have three takeaways. One is the visualization, right? We have started with an informal definition of visualization. Then we have learned the history. Then we have learned the formal definition of data visualization. Then we have seen what is the need of data visualization, why we need it, why businesses needs data visualization, because they need to take decisions. And the role of a data science professional is to identify relevant data, uh, ask questions, ask relevant questions to this data, find out the analytical right results, then visualize the findings and communicate that with the decision maker so that they can take better decision to deal with the business, right? And the third one that we have seen are the tools and libraries, that are the famous libraries which can be used for visualizing complex data or even graph visualizations, etc. So these are your key takeaways from today's session. I believe I was able to convince the relevance of data visualization in the context of data science. As you will be having a hands-on session, keep all these things in mind. When you have a data set, you are seeing a data set, keep all these things in mind, and then apply the relevant chart or plotting techniques as directed by the instructors. And I'm sure that you will be like, if you understand some of the trends and techniques that we have discussed now, the hands-on sessions will be very, very easy for you, right? So thank you for listening to me for this 1.5 hours.